I assume anyone brave enough to sit through the 7 minutes that I'm about to combust off of the life would never have heard of the definition or the ideology of solar energy. In essence, solar energy is simply to harness and exploit solar radiation via various medias in order to support the industrial activities performed by modern Homo sapiens. The goal of this train wreck in specific is to traverse into the science wonderland and explore the futuristic revolution of this technology. Before I stretch my two only functioning brain cells to comprehend the complexity behind the technological advances and geniuses of the beloved and well-adapted solar panels, let's read through the brief history of this science field in energy production. In late 19th century, solar-powered machinery began making their appearance in the industrializing world, including powered by steam-transported Beyblades, kitchen ovens, and particle acceleration systems, which took advantage of solar thermal energy to operate. These machines were a decent alternative to using fossil fuels, which can eradicate the environment over a period of centuries of unsupervised exploitation. One of the major pioneers of this movement, Frank Shuman, ordered the construction of the first ever power plant that draws heat from the sun as a main input in 1910s-ish, solidifying his vision for pollution-free energy source in the drought of unrenewable fuels. Backtracking a bit, in 1839, a young physicist named Edmund Becquerel laid the scientific foundation for future renovations into solar panels. He discovered the photovoltaic effect, where certain materials, quantum semiconductors, could articulate electricity when exposed to solar illumination. On account of this novel discovery, many scientists and engineers have replicated countless projects and eventually succeeded in putting together a rough amalgamation of a solar cell. These components in a massive array make up a hypothetically functioning solar panel, albeit horrendously inefficient, and only by mid-20th century was the machine commercially feasible with the inclusion of silicon in the mixture. That said, the following entities represent my personal attempt at conveying to equally bored attendants of this stale time stream the mathematical logic of thermal and photovoltaic or solar radiation and how they translate into electricity, as well as reporting on their current practical capability in global consumption. Talking heat and elevated temperature, we first liquefy our cognitive organ into condensed salt. The main procedure behind solar thermal electrons go is a positional utilization of reflective surfaces in order to concentrate sunlight on adapted devices in which a chemical compound is bacon boiled to liquid and convert the resulted heat into thermal energy that runs a typical turbine system to produce light bulb juice. Authenticating this theoretical process, a number of mechanical applications have been developed, housing many optical variations, ranging geometrical layouts and distinct efficiency output based on two operational mechanics, linear or point focus. One such complex is the Parabolic Trough, a military line of identically powerful reflectors in the arrangement of a parabola curvature. Modifying light rays by means of linear reflection, the machines attract immense heat to the receiver's end, a water pipe of literal molten salt. Another model that employs the same method is Fresnel Reflectors. Using planes instead of concave mirrors, these reflectors compilation, while rather economical and versatile, yields less desirable fruit. The upcoming technology of ray tracing may prove that wrong. In terms of point-centric blueprints, the towers are very reliable at what they do. The plentiful alignment of steel sunflowers, better known as heliostat, tracks sun's light trajectory and concentrate heat rays towards a receiving chamber atop a tower. One of the most probable design, not only is the construction less monetarily heavy, but also provides advantageous output. A similar model applying the same principle is dish stirring. These television signal plates sport a compact and neat appearance in addition to built-in aimbot. While not the most colossal and heavy-duty, dish stirring has proved to bear the most efficient solar-to-electricity decryption, i.e. least amount of potential energy loss during production. Photovoltaic, on the other spectrum, is halfway along quantum physics. Light in its most fundamental existence is photons moving at time travel speed. These atomic particles, when distributed to the surface of solar panels, knock electrons off their stable state into a basic electrical flow, which is then harvested. The heart and soul of the entire operation is solar cells. These are miniature solid sheets of battery infused with semiconductors. As the name implies, absurd numbers of cells are arrayed into behemoth modules for maximum workload. Semiconductors are elements with electrical conductivity varying according to their temperature. The most viable enabler is crowned by silicon, taking the shape of crystal bulk to standalone bulk to ribbon or straight up remove silicon from the equation for thin paper of conductive formulas of copper or gallium. Heck, by stacking the cells, engineers have created metamorphosis monstrosity of muscularly enhanced panels that retain substantial efficiency. Furthermore, solar batteries also offer excessive versatility in terms of flexible installation in almost all imaginable surfaces and angles, let alone options for aimbot models. This kind of energy possesses extraordinary potential. One obvious competitive edge solar power wields against fossil fuels is that environmental contamination is virtually non-existent throughout the whole process of fabricating solar conducted electron stream, not to mention the sheer considerable return in voltage compared to other renewable energies. Generating a couple thousands of megawatts per year, that figure is at minimum sufficient to support at least two medium-sized microwave. Another amazing advantage assisting the allocation of solar in powder commission is manufacturing God mode and declining bugs leading to accelerating availability, avalanching the majority of the population. In particular, molten salt in concentrated solar plants can be stored in hyperlock and lock insulated storage canister for later production, whilst panels are expediting its commercial cost down a waterfall, making domestic grid an achievable reality. With that in mind, high-end top-notch techie chemistry is not only for monotheistically manufacturing electricity. In fact, the physical reaction between solar downfall and numerous factions of materials means that it can also be utilized in the condensation of useful goods such as batteries. However, the development poses several setbacks. The most prevalent and problematic shortcoming of solar energy is its reliance on weather configuration. Sun-based generators depend almost parasitically on the attendance of the humongolongo fusion mat spherical. Without it, fundamentally, solar energy production is halted to a radical extent. This in itself already degrades the solar attraction of this technology by attributing unreliability to it, and to make matters worse, the output in return, while exponential in terms of evolution, is still measly lackluster to say against regular natural gas and coal. One other widely regarded roadblock is geographical limitation. Solar energy complexes require the grand spaciousness of landscape for optimal assembly and management. Thus, the minor category of geographic profiles that deem reasonable orbit somewhere around desert lands and/or plains. Only the vast atmosphere would allow panels and mirrors to work to the utmost capable extent. To add on top of this hassle, the suitable environment, mainly deserts, are usually a continental distance away from actual residential location, making the transportation of solar electricity from mainstream grids to citizen households a rather tricky and expensive matter for project operators. To conclude, I am more than astounded at what big brained people have come to formulate and engineer in the breakthrough of clean energy production. Admittedly, development is still in primitive stages and obstacles are unavoidable, but the sheer potential that dwells in these colossal solar factories, what lies the future solution to our supposedly possible energy crisis, all of which gives me more excitement to envision a planet with not fuels, but literal stylized windshields breathing life into Wi-Fi modems.